Hello, this is Michelle Hobbs, and I am going to be taking the exam 3 um, practice test part 1. Let me share my screen. Share room. There we go. Okay. All right. So question number 1. A school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. The claim the proportion is 61% can be written up as P equals 0.61 because P equals 0.61 contains a statement of equality. It becomes the null hypothesis. In this case, the null hypothesis represents the claim. I'm going to open up the review video.
State the null and alternative hypothesis. Write the claim as a mathematical statement. State the null and alternative hypotheses and identify which one represents the claim. So take a look. Here you have a school publicizes that the proportion of its school's students who are involved in at least one extracurricular activity is 61%. So you basically can just ignore this part of the statement because the school claims something about the students and the claim is about proportion. It says that proportion is exactly 61%. So when it comes to verbal statement for null and alternative hypothesis about the proportion, we are representing that by P. So since it says it is 61%, we are working with this scenario equal to 61%, 61%, exactly 61%. The claim, the proportion is 61% can be written as P or population proportion 0.61 or 61%. The complement, which is going to be your alternative hypothesis, is written this way, not equal to. So the school says, hey, the proportion of students involved in extracurricular activity is 61%. Is it true? Is it false? We need to investigate that. We need to test that hypothesis. You might go to the school and ask some students, and they say, no, we are not involved in extracurricular activity. And then after running the test, you're going to reject the claim of the school. So we don't know the truth or falsity at this time. We are just writing the null and alternative hypothesis here. The null hypothesis says the proportion is 61%, its alternative, its opposite, its complement is not 61%. It might be less than 61% or more than 61%.
Okay, so the claim is 61% because P contains the statement of equality. It becomes the null hypothesis. In this case, the null hypothesis represents the claim. I'm a little confused because I think it's false.
Opposite comes writing the null of an extracurricular activity. Is it true? Is it false? We need to investigate that. We need to test that hypothesis and ask some students, and they say, no, we are not in. You're going to reject the claim of the school. So we don't know the truth or falsity at this time. We are just writing the null and alternative hypothesis here. The null hypothesis says the proportion is 61%, its alternative, its opposite, its complement is not 61%. It might be less than 61% or more.
So I think that this is I think it's false because we don't know the claim yet. We don't know if it's true or false, so I'm going to say false. I hope that's right. I hope I understood that right. Okay, question 2. The p-value for a hypothesis test is p equals 0.0237. What is your decision when the level of significance is 0.05? I'm going to open up the video.
In this question says, well, you have some p-values and some alpha. What's your decision about the null hypothesis comparing alpha with p-values? First of all, remember that as long as p is less than equals to alpha, you're going to reject the null hypothesis. Otherwise, you're going to say that, hey, we fail to reject the null hypothesis, or basically support the null hypothesis. In the first case, your p-value is about 5%. All right. If you round this, you get about 5%, but it is less than 5%. 5% is compared to 1%. Since 5% or 0.0461 is more than 1%, it means that you fail to reject the null hypothesis, or we support the null hypothesis. Now let us compare p-value with alpha, which is exactly 5%. So basically, you see this number is less than 5%. Since p is less than alpha, which is 5%, based on the definition, you say that, hey, you reject the null hypothesis. Now for the third case, you have 10%. Your alpha is 10%. Of course, this p-value, which is about 5%, is less than 10%. So in the third scenario, p-value, which is 0.0461, is less than 10%. So based on the definition, you're going to say that you reject the null hypothesis.
Okay, so let me see here. So the p-value for a hypothesis test is, so what is your decision when the level of significance is 0.05? Um, I think the p-value for a hypothesis test is p equals 0.0237. What is your decision when the level of significance is 0.05? Um, I think it is. I think we're rejecting because of the level of significance. There is 0.05. Excuse me. The p-value. Oh, okay. So let me think here. Um, the p-value for a hypothesis test is p equals 0.0237. What is your decision when the level of significance is 0.01? I think for this one, it's going to be um, that we fail to reject because we compare the p-value to the level of significance. And if P is greater than the level of significance, then we fail to reject it. So since the level of significance is 0.01, that is less than P. Okay. Find the p-value for a left-tailed hypothesis test with a standardized test statistic of z equals negative 2.23. Round to 4 decimals. Let me see here. Take a look at this video real quick. Oh, don't want to do that. Open this. Okay.
This question, you want to find a p-value for a left-tailed hypothesis test with standardized test statistic z equals to negative 2.23. So since we have a left-tailed test, the graph looks like this. And since we have the z value, we want to find the p-value, which is the area to the left-hand side. Let's take a look at our calculator. We need to go to second. It could be a very small number, like what? Like then the up matrix. Again, this is the graph that we are looking at. With negative sign, the mean is 0, standard deviation is 1. So we can calculate the p-value, which is 0.012873. And since the question says round to 4 decimals, the answer is 0.0129 because we need to round it up.
Got it. Okay. So we are rounding after the calculation. So it's 0.0129. 0.0129. Next. Excuse me. I'm so sorry. I just got off work. Find the p-value for a two-tailed hypothesis test with a standardized test statistic of z equals 2.14 and round to 4 decimals. Okay, I will take a jab at this using my calculator. So, I think so the p-value for a two-tailed test is 2. So I calculate the p-value and using the standard normal distribution calculator table or a calculator. It is gonna be, I think I have the answer, but I just want to make doubly sure that I'm right. So let me look at this.
In this question, we want to find the p-value. The half is on the right. So give it a positive number was
two-tail
and find normal CDF right here. To positive number like 10 or 100. We're going to find this little area and multiply that number by 2. So let me find and when multiply by 2, we have 0.03235.
Yep.
And since the question says round to 4 decimal places, we're going to write that point 0.324 and 4.
Yep, that is what I got. So 0.0324. 0.0324. Okay. Excuse my cat meowing in the background. Okay, let's see here. Auto racing, a pit stop is where a racing vehicle stops for new tires, fuel repairs, other mechanical adjustments. The efficiency of a pit crew that makes these adjustments can affect the outcome of a race. The pit crew claims that its mean pit stop time for 4 new tires and fuel is less than 13 seconds. A random sample of 32 pit stop times has a sample mean of 12.9 seconds. Assume the population standard deviation is 0. Where was I? 19 seconds. Is there enough evidence to support the claim at equals 0.01? Use the p-value. The standard deviation. So you can use the z-test. The claim is the mean pit stop time is less than 13 seconds. Okay. The level of significance is 0.01. Okay. So let's see. I'm gonna have to open this one up just to walk through it again.
Hypothesis is using the p-value. In this example, we have auto racing
So I read
of the
all of that.
race.
I'm gonna skip that
Claim
part.
less than, right? The atom, this is your level, your sigma or population standard deviation is given to have any problem here. What's the level of significance? The level of significance in the question given to us, it's 0.01%. Now we need to move on to calculate the standardized test statistic minus mu, which is populate of n, 13 seconds. So alternative hypothesis, if you go back to the first page, the alternative hypothesis is less than 13 seconds. So you have a left-hand graph. The area to the left-hand side of negative 2.98 is 0.0014, which is a very small u. That the mean stop time is less. We calculated the standard side of negative 2.98, which is a very small area, and it's less than 1%. So based off of p-value is less than 1%, we reject the null hypothesis. Here,
Okay, let me understand the
there is
breakdown.
enough evidence at 1%
The
level
value
of
in the red
significance to
box.
support the claim that the mean stop time is less than 13 seconds. In summary, if you look at the summary here, and we're following the steps, we
13, I think.
calculated the standardized test statistic based off of that, and that we have a left-hand graph. We found p-value, which is the area on the left-hand side of negative 2.98, which is a very small area.
So
it's less
13
than
seconds. And then because this is a left-tailed test, the p-value is equal to the area. So p equals 0.0014. 0.0014. 0.0014 because the p-value is less than the value in the green box. You reject the null hypothesis. So value in the red box is 13 seconds. The value in the blue box is 0.0014, and the value in the green is you reject. Okay. We're going to pull, this actually helps me with locating where the answers are on these things. Question 7. All right, I'm going to try to figure this one out. Zoom in real quick. Oops, I need to mute real quickly. Sorry, one moment. Sorry, my son was asking me a question. Sorry about that. Okay, moving on. According to a study, the mean cost of bariatric weight loss surgery is 21,500. You think this you think this information is incorrect. You randomly select 25 bariatric surgery patients and find that the mean cost for their surgeries is 20,695. From the From the past studies, the population standard deviation is known to be 2250 and the population is normally distributed. Is there enough evidence to support your claim? Okay, let me see at population order. You can use the z-test. The claim is the mean. So the null and alternative hypothesis are okay. I think I can figure this out. Um, I have to look back at this though, because I forget where to plug in the stuff. Okay, looking back at this one. Hold on a minute. So 2695 minus I think it's 21,500. I will try that. And then the value in the blue box, so 21,500, which is right here, the claim. And then 2250. I'm looking at this second number here, 32. The sample is random. Sorry, I'm looking at this other example. And equals 32. Mm. You think that's it? You randomly select 25. I think the number that goes in the blue box is going to be 25. And then the value in the green box, because the test is two-tailed, the p-value is equal to twice the area to the left of z. So this is going to be, let's see. Okay, let me see. equals 1.79. Negative 2.98 on this one. So the p-value, because this is just a 2, oh gosh, 0 point, hold on a minute, 0.00014. Okay, so p equals let me see here. Because the test is a two-tailed test, the p-value is equal to twice the area to the left of z equals negative 1.79 as shown in the figure at the left. So p equals 2. P equals 2 times 0 point what? I think so. Calculate the p-value by multiplying. Oh yeah, multiplying by 2. So negative 1.79 is going to be, once I put it in my calculator, 0.0 367. And then let's see. And then 0.0734, I think. And so then if the p-value is greater than, oh wait, because the p-value is greater than 0.5, you fail to reject. P-value is less than the significance level. P-value is, so wait, the significance is, wait, so because the p-value is greater than, oh, it says the p-value is less than, so that's a false. Oof. It's always hard to figure all these placements out. All right, next. Okay. Let me see the example open.
So now we're analyzing the case that we are checking the hypothesis testing for population mean and sigma, the population standard deviation is missing. Let's take a look at one example together. In this example, we have a used car dealer claims that the mean price, keyword, mean price of a 2-year-old sedan in good condition is at least guys, keyword, at least $20,500. You suspect this claim is incorrect. As a statistician, you're going to randomly select 14 similar vehicles and you're going to calculate the mean and the standard deviation of your sample. So all of these information are about your sample. The mean price of the sample is $19,850 and the standard deviation is $1,084. So as you can see, the standard deviation is for the sample, it's not for the population. Question says, is there enough evidence to reject the dealer's claim at 5% level of significance? Well, let us take a look at that word. In the very first step, you're going to construct your null and alternative hypothesis. Step one, what is the null hypothesis? What is the alternative hypothesis? Remember that we have a keyword, at least. Keyword, at least. At least is larger than or equal to. Since it has equality, it means that the null is given to us. So null hypothesis says, hey, the mean price is larger than or equals to $20,500. This guy is the claim of the dealer. So you're going to write the claim next to your null hypothesis. This is your claim, C. The alternative hypothesis, the opposite of larger than or equal to, is less than. Mu is less than $20,500. Okay. Now, in the second step, we need to have a standardized test statistic. Standardized test statistic. Well, is it going to be Z equals to X bar minus mu divided by sigma times square root of n? Or is it going to be T equals to X bar minus mu divided by S times square root of n? Which one it is? Which case is that the one that we're working with? Is the Z or is the T? Remember that. The question says, we don't have any information about the population standard deviation. This guy is missing. Sigma is missing. So we are not allowed to use Z. We need to use T. It means that we are not allowed to use normal CDF. Normal CDF is not allowed. You're going to use a T distribution. Okay, so let me find T. T is going to be X bar. The mean of the sample is $19,850 minus the mean, $20,500 divided by S, sample standard deviation, 8,084 times square root of n, and the sample size, 14. Well, if you do the calculation, your T is approximately negative 2.244. We're using T to find a p-value. Step 3, use T to find the p-value. What's the p-value? That area to the left-hand side of your T. Remember that it's a left-hand graph. If you look at your graph is a left-hand graph. Because your alternative hypothesis is less than, it means that you have a left-hand graph. So we want to know what is this area, what is this p-value to the left side of negative 2.244. So you have two options. You can use an online calculator like this website. You can enter your t-score here, the degrees of freedom, which is n-1, and you can use a significance level, which is 5%. And since you have a one-tailed graph, use one tail, and the p-value is going to be 0.02144. This is the website that you're using.
So the DP, wait. Oh, degree of freedom. Oops. Is 13. And then the T-score, the level of significance I wrote is, oh, I need to make sure I wrote that right. Yeah, 0.05. And then one-tailed or two-tailed. Negative 2.244. Negative 2.244.
The T-score, degrees of freedom, 14 minus 1, which is 13. Level of significance, 5%. One-tailed hypothesis testing. And the p-value is 0.02144. So the p-value of this area is about 2%. Step 4. Now check to see if p-value is less than equals to alpha or not. Well, p-value is almost 2%. Alpha is 5%. Obviously, 2% is less than equals to 5%. Since 2% is less than equals to 5%, so we reject the null hypothesis. Okay, we reject the null hypothesis. Now take a look at the hypothesis here. The null hypothesis and the claim are the same thing. Since the null hypothesis and the claim are the same, we reject the claim. We reject the claim as well. Okay. At 5% level of significance, we reject the claim that the mean price is at least $2,500. Let me show you how to use your calculator.
Wait a minute.
So to use your calculator, turn on your calculator. Let's see, let me clear this and put this in a box for you. Calculator. So turn on your calculator, go to stat, and then go to test. So go to test. Okay. Okay, we already selected this. So let me just erase the whole thing. I think my calculator needs to be resetted. Second plus. And let me go to reset, all RAM, reset, and second plus. Reset the defaults. Perfect. So go to stat, go to tests. Still going here. Shouldn't we go to z-test? Let me see.
Okay, and I just entered in all of that according to everything. Okay.
A researcher claims that less than 40% of US cell phone owners use their phone for most of their online browsing. They have a random sample of 100 adults. 31% say that they use their phone for most of their online browsing. At 1% level of significance, Is there enough evidence to support these researcher claims or not? I'm going to apply two methods using rejection region, and then we're going to move and use p-value. For the rejection region, first you need to check to see if NP is more than equals to Q5 and NQ is more than equals to 5. So since N is 100, you have 100 adults in this survey, and the probability of successful population is guessed to be 40%. We're going to multiply these two. 100 times 40% is 40. So we're good with the first one. N times Q. Q is the probability of failure for the population. 1 is 40% is 60%. So 100 times 60% is 60. We're good with both of these numbers. Now, let's identify the null and alternative hypothesis. Note that the keyword given to you is claim that less than. Since you have less than, it means that it is your alternative hypothesis. Alternative hypothesis says, I'm guessing that the population proportion is less than 40%. This is your claim, and this is your alternative hypothesis. Because of that, you have a left-out test. You can easily build the null, which is the opposite. So it says, hey, the proportion, population proportion is more than or equals to 40%. Now that we state the null and alternative hypothesis, we identify alpha, which is 1%. We use alpha and the fact that it's a left-out test to find. Let me show you how to use a calculator to find this z. So let's go to the calculator and let me share the screen with you and show you how to use your calculator to find z. So first of all, you need to go to second, then bars. And since here you have the area and you want to try to find z, the function is inverse norm. The area is 1%, so 0.01. Why? Because your alpha is 1%. And here you have a left-out test. Mean is 0, standard deviation is 1, and it's a left-out test. So go to paste and do the calculation. And as you can see, it is negative 2.326. So basically, you can say that it is negative 2.33. This is your z sub 0, which is the z-score related to the area to the left-hand side. Very good. Now that we found z sub 0, we can identify the rejection region. Any number less than negative 2.33 is in the rejection region. So we need to find out, standardize the statistic, decide if that number is inside the rejection region or not. This z is p hat minus p. P hat is the probability of success in the sample, which is 31%. 31% minus 40% divided by square root of p times q. P is for the population, guessed population. This is our educated guess about population. So 31% minus 40% divided by p is 40%, q is 60%, divided by 100. This number, round to 2 decimal places, is negative 1.84. But comparing these two numbers, negative 1.84 is not less than this number. It's larger than this number. So it means that your standardized test statistic is outside the rejection region. But what's the meaning of that? Since z is outside the rejection region, you're going to say that, hey, I fail to reject the null hypothesis, or we support the null hypothesis. When you support null, it means that you reject alternative. In this example, claim and alternative are the same thing. So we are rejecting the researchers.
And that is my part 1. Thank you.